Hello everyone. What we're going to focus on in this video is translation. And you may ask, what is translation? A translation is a slide from one location to another. A translation is not a change in size or orientation. Right? So that's basically what a translation is. Right? Examples of translation. Well, let's say you have a person on a skateboard, right? And that person skate from point A to point B. Then that would be an example of a translation. Let's say that you shift your phone from one point on a table to another point on a table. Then that's an example of a translation. Let's say that you move from one point in your house to another point in your house, then that's an example of a translation, right? Even my screen here, when I slide from one screen to the next, that's an example of translation. So what we're going to do now is to look at some properties of translation. Some of the properties of translation are translation preserves size. So that's one of the key properties that you must always remember. After you have done a translation, the size of your image will not change, right? So the same size that you started out with, it will be the same size that you will end up with when you complete that translation, right? Another property is that translation preserve angle, right? So all the angle in your object that you started out with will equal to the same angle in your image. So the corresponding angles will be equal, right? Translation preserve parallelism. Now, the same side, corresponding side, will be equal, and also they will be parallel, right? Translation preserve area. Well, the area of your object, or otherwise known as your pre-image, right, is going to equal to the area of your image after you have completed your translation. So that's another property. And translation preserve orientation, right? So for example, if you have labeled your object in an anti-clockwise direction, right? And after you have done your translation, then you would have noted that your image would also be labeled in an anti-clockwise direction. So which means that it preserves orientation, right? Translation also preserve order of points. So the same order in which the points are in your object, it's the same order the points will be in your image, right? And translation preserve length, right? So all the lengths that you have started off with, the side of whatever figure or object that you were translating, will maintain that length, right? And what I'm going to do as we go forward is that we're going to look at this property more in depth and from a graphical perspective, right? These are some pictures of translation, right? So you can take note of these pictures, right? Now here on my screen I have a right angle triangle, right? And this right angle triangle, I have the area of the right angle triangle. So it's triangle ABC, and triangle ABC has an area of 30 square units. The length of AB is 6. The length of AC is 11.66 units. And the length of BC is 10. We also have angle ABC to equal to 90 degrees, which is the same thing as angle A here. Angle beta, which is the same thing as angle ACB, or angle BCA, is actually equal to 30.96 degrees. And we have angle BAC, or angle CAB, which is the same thing as angle Y here, being 59.04 degrees. Now, this measurement will help us to justify the different properties of translation that we have mentioned before. So what I'm going to do, I'm going to translate this triangle by a vector, right? And first, I need to select a vector, and I am going to select vector. So the vector that I want to use to translate this triangle is going to be a vector from the origin. So let's put a point at the origin. And let's say that I want to move each point on this triangle 5 units across, right? And let's say 4 units up. So it would take me to this point here. So this is the vector that I want to use to translate this triangle. And what the vector does, it tells you in which direction I'm going to move each point. So I'm going to move them 5 units across first, and then 4 units up. All right. All right. So there is my translation. So here is my image, and note that my image is being named A prime, B prime, and C prime, right? We did say that one of the property of translation is that it preserves orientation. Let's check that. Here in the object, I was going from A, B, C, which is an anticlockwise direction. In the image here, I'm going A prime, B prime, C prime. So absolutely, the orientation preserved. We also say that area is preserved. We know that the area of triangle ABC is 30 units, so we need to check the area of the image, right? But before I check the area of the image, I am going to put the image in a different color so that it is easy to distinguish between the image and the object, all right? Now the image is in the blue color, right? All right, so let's check the area to see if the area is the same. Okay, so when we compare both areas, they are the same. So the area of A prime, B prime, C prime is also 30 units. So that is another property that we can observe, right? Let's see if the angles are also preserved. So let's check that. So let's check angle C prime, B prime, A prime. Okay, so that is also 90 degrees here. So this angle at angle CBA is 90 degrees. Angle C prime B prime A prime is also 90 degrees, right? You can just shift this B here outside so it's not so curly. So you see the B prime, all right? So we realize that the angles are preserved, right? And we could do another one to make sure that all the angles are the same. So let's test another one. So we are going to test B prime, A prime, C prime. And that angle is also 59.04 degrees. And this angle. So the corresponding angles maintain. So angles are preserved. So that's another property after cancellation has taken place. Right? We did have the lengths of the side. So we have the length of AB equals 6. Let's check the length of A prime B prime to see if it is also going to be 6 units. Oh, of course. So that corresponding length is also 6 units. So absolutely the lengths have preserved. And let's check B prime, C prime to see if it is the same length as BC. Yes, BC here is 10 units and B prime, C prime is also 10 units. And let's check the final one, which is C prime, A prime. C prime, A prime, that is 11.66 and AC is also 11.66, right? So, of course, the lengths also preserved. And if you note here that A prime, C prime is parallel to AC and also B prime, C prime is parallel to BC and also AB is parallel to A prime, B prime. So parallelism are maintained. All right. Now what I'm going to do, I am going to check one more thing, check another property, right? And what I want to check is if all the points are at equal distance apart, all right? So I'm going to check to see if all the points are at equal distance apart. So what I'm going to do, I'm going to connect the corresponding point. So I'm going to connect A to A prime. I'm also going to connect B to B prime. And I'm also going to connect C to C prime. And then what I'm going to do is to test to see if all these points are at an equal distance apart. So I'm going to check. So I want to know what the length of A to A prime is. So I'm just going to tab here to see what the length is. Okay, A to A prime, that's 6.4 units. Let's see if B to B prime is the same 6.4 units. Absolutely. B to B prime is also 6.4 units. And C to C prime is also 6.4 units. So by just observing this graphical representation of translation, there is a lot of properties that we can observe and we can see for ourselves. All right. Okay, what I'm going to do now, I am going to make this point here at E, movable, so that I can change the vector, and to see if I change the vector, if this property will hold true, right? So I'm just going to select the point here, and I'm going to go to here, and I'm going to select move. All right. So which means that this point is supposed to be able to move along, right? So I can move it. So note, if I change the translation vector now, and I now change this vector, where it now have a movement of 10 units to the right and 4 units up, you would note that each point on this and the image will move along with it, right? And all the properties that we have just identified would also maintain. If you look at the area is 30, right? Doesn't change, right? The area is still the same, right? What have changed is the distance between the points, but they still maintain true for each because it is now 10.77, right? The angle still remains the same, right? The angle has not changed, right? Let's say that we change the direction of the vector now, and we are going in this direction here, and we're now saying that we're going 3 units to the left and 3 units up. Would it still maintain? Now what we can do is to just zoom in, and if you would take a note on what is happening, that the properties still maintain, right? The area is the same for both, right? So here the area is still the same, the length of corresponding side is still the same, and it doesn't matter. It doesn't matter by which vector you translate an object by, it will hold true. All the properties will hold true, right? If I change it to this direction, right, where I am now going 8 movements to the right and then 4 units down, then it still will hold true. Let me just adjust it so you can see it.